So yesterday and the day before, but yesterday we talked about transformations of functions, linear functions specifically. Okay? And we talked about what happens if you make one change, how one change affects one thing, right? Today we're going to talk about what's called composite transformations. This just means that, so a composite transportation, that's what goes, transformation, sorry, composite transformation. Okay. A composite transformation occurs when two or more transformations are performed on the graph of a function to produce a new function. Okay. So all this is when that you have combined things that happen. So instead of only one change happening, you have multiple changes happening. Okay. To determine which transformations have been applied to an absolute value function, that's a typo. This needs to be linear function. We're talking about linear functions. Okay. Consider the following questions. However, all these transformation rules apply to all functions. They just look different with different functions, but they're all the same principle, same thing happening. So when we're looking at composite transformations, the first thing, okay, so the very first thing you're going to look for is whether or not there's a reflection. And on our notes yesterday, we learned that the reflection is when something is multiplied by a negative, right? So if there's a negative being multiplied in there, then it causes a reflection. So here's some examples. So right here, there's a negative in front of this x being multiplied by the x. Okay, right here, there's a -5. Okay, but it's the negative sign that causes the reflection, not the 5. Some non-examples, notice that there's nothing in front of this x. Okay, so it's a positive there, so it's not a negative. And then 1/2 is also positive, not negative. So these non-examples do not have a negative sign, and these examples do have a negative sign. When reflection happens on the graph, okay, it changes the slope. It changes the slope from positive to negative. So if it's going uphill and it has a reflection, then it's going to change and go downhill. Okay, so a reflection makes it switch from going uphill to going downhill, or vice versa. Okay, a reflection can also make it go from a negative or a downhill to a uphill positive. Okay, so the second step is vertical and horizontal stretch. Keep writing on mine. Okay. So notice on this paper that I gave you, or that you picked up at the back that was colorful, okay, notice that we have new words that we didn't talk about yesterday called dilation. Okay, so we've got vertical dilation and horizontal dilation. Those are just the words that encompass stretching or compression. Okay, so instead of saying stretch and compression or stretch or compression, you can use the word dilation to mean both. Okay, dilation we don't typically use when we're talking about linear equations or in algebra. But it is used a lot when you move to geometry, because when you're talking about two-dimensional shapes, they get smaller or bigger. So you can see the dilation more in that respect. Okay? So the words that we use in algebra are more steep and less steep. If you choose to use stretch or compression, you have to also pair it with vertical or horizontal. Because vertical stretch is the same thing as horizontal compression. So you can't just say compression without also saying either vertical or horizontal. Does that make sense? So that's why we try to simplify it by just saying more steep and less steep. So what would go here in this blank, it says stretch and compression changes the steepness of the graph, y equals x. And some examples, okay? So this number that's being multiplied in front of the x here, 0.2, is it greater than 1 or less than 1?
Less than 1.
Less than 1, okay? So notice right here, if this number being multiplied out front here is less than 1, if it's between 0 and 1, then it's being vertically compressed, or it causes the graph to look shorter. Okay? Over here, if it's horizontally stretched because it's from 0 to 1, it makes it look wider. However, we would use the words less steep because it's less than 1. So here we're looking at the 5 that's in front of the x. Okay, the negative we already dealt with the reflection. So is 5 greater than 1 or less than 1? Greater than 1. So my steepness would go up. It would be more steep because 5 is greater than 1. So it would rise faster than it runs. Non-examples of things of the horizontal compression or vertical stretch happening is when we still have a 1 in front here. So we have 1x, so a 1 doesn't change anything from the 1 that's in our original. Okay? And right here, -1, the steepness doesn't change, only the reflection changed on that one. And our third step, okay, is vertical and horizontal translation. Okay, this is a shift. Okay, a shift that happens. Okay, notice that both reflection and the stretch or compression of the graph deals with it being multiplied, deals with something being multiplied to the variable. The translation deals with things being added to or subtracted from the variable. That causes a shift. So adding or subtracting causes a shift. So here's an example, okay, of -5. So how is subtracting 5 going to change your graph? You're right. It's going to bring it how? Down. It's going to bring it down 5. Okay, over here, if I'm going to add 1 to the end, how is that going to change it? It's going to bring it up 1. Okay, so this third step, all we're looking at is what's being added or subtracted on the end. Okay, notice in the non-examples, there is nothing being added or subtracted. It's just a number times x, a number times x. So the translation changes the location of the intercepts. Okay. we tend to just look at the y-intercept because it's more common sense. Remember how we looked yesterday at when the x-intercept changes, it's actually backwards of what it looks like. So we use the y-intercept because it's less confusing. So down here at the bottom, okay, so the instructions say the graph of the function g was obtained from the graph of the function y equals x using a composite transformation as shown on the grid below. Describe how the transformation affects the slope and y-intercept of y equals x. So the first thing that I'm going to do is I'm going to graph this y equals x just so I can see the change. Because this is the new graph, okay? What they have is g. This is the new graph, okay? So g is the new graph. This one is the original, okay? So I want to graph my original so I can see the change. So my original starts at the origin, has a slope of 1. So it's going to go through the graph like that. I'm not going to make it a line because I just need to be able to look at it to kind of see what's going on. So, but that's f. That's the f of x line. Okay. I'm going to rewrite that new over here just so that it's clear that it's talking about the g. Okay, and the f is the old. So looking at my old graph, which is the f of x line, and the new graph that they gave me, was there a reflection? Because that's my first step. Check for a reflection. Was there a reflection, or they both still have a positive slope? They both still have a positive slope, so there was no reflection. So what's the second question that it says to look at? Okay. So the second thing is the vertical and horizontal stretch. Okay. We can say the steepness. Okay. So if we're looking at this, how did the steepness change? Did it get more steep or less steep?
More steep.
More steep. Okay. And then the last question is, did it shift any? Did it translate any? And we're looking at our y-intercept when we're looking at that. So if I started out at 0,
Yeah.
then how did it shift?
Over 1.
Shifted. Well, we're gonna look at the y-intercept. So how did it shift on the y-axis?
Down to.
It shifted down 2 units. Okay. It shifted down 2 units. So I'm going to go ahead on this next graph, and I'm going to go ahead and graph my original graph so I can see my change. Okay, so here's my f. This is my old. Okay, and g is my new. Okay. So the first thing is to look at whether the slopes, whether it got reflected or not. So are both of them still positive, or did one flip to be negative?
What was the question?
So the first step, right, is to check for reflection. So are they both still positive or did one flip? One flip. So there is reflection. So it reflected. And then the next question is about the steepness. Did it get any more steep?
No.
Okay. It actually didn't. So it's up 1/1, right? So my original slope is 1/1. My new slope is up 1, back 1. So it's still 1/1. Right? It just has a negative. So that's where the reflected came in. So same steepness. And then the last question is, did it shift any?
Well,
So we got to look from the origin or the y-intercept. So did it change on the y-intercept?
yes.
Yes. How did it change?
It went up 1.
So shifted up 2 units. If you're finished writing those notes, then get your next parent function graphed on that next example.
Can I go to the restroom?
Can it wait till we're done? I mean, if you have to go, you can go.
Oh,
But if it can wait, then we'll try to hurry through it. So we've got our F, which is our old, that we plotted so we could see it. Okay. And then we've got G, which is our new, right? Was there a reflection? Did one go from a positive slope to a negative slope?
It's negative.
So this one was positive, that one's negative, so it was reflected. What about the steepness?
Yes. Steeper.
Did it get steeper or less steep? So this one,
Less steep.
so one way you can look at it is if you pick a point on your y-axis, even if it's flipped, and measure. So my new one, on this spot on the y-axis, changes by 1. And the old one went up 3 at that same point, right? So 1 is less than 3. So did it get more steep or less steep?
Less steep.
Less steep. Okay, and then did it shift any?
No.
No shift. They both went through the origin. Ready for the back side? So on these examples, it says the parent function f of x is shown on the grid. So it's already graphed for us. So the original line is already graphed for us. Graph g of x on the same grid and describe how the transformations on f that result in g affect the slope and the y-intercept. Okay. So my original function is f of x equals x. That's the original function here. In this handout that I gave you, anything that's horizontal changes inside the parentheses. If there's no changes inside the parentheses, That actually makes the problem easier for you. Because I can look at this and say, okay, did I have any changes that happen inside my parentheses? Are there any changes that happen inside this?
No.
No. If there's no changes that happen inside the parentheses, then that means f of x stays the same. So I can substitute x right in there for that spot and make it look prettier. So I know what to do with it. So g of x equals 1/2 x minus 4. Do I know how to graph this now? Does that look more familiar?
Yes.
Yes. So where am I going to start?
-4.
At -4, at my y-intercept of -4. Then what do I do next?
So up 1/2.
Up 1/2, use my slope, up 1/2. Graph all my points, draw my line. This is my new G. Do you have to graph it to know what changes would happen? You don't have to, right?
No.
But if you prefer to look at, you're more than welcome to graph it and see what happens. But what does this 1/2 in front of the x tell me?
There's no slope.
That the slope. And is 1/2 steeper or less steep than 1? Because in my original, the slope was 1.
Steeper? No, less steep.
Less steep, right? 1/2 is less than 1. So it's going to be less steep. Was there reflection? Was there reflection?
No.
No reflection. How did my y-intercept change?
It didn't. Wait. It moved down again.
It moved down 4. Is that what this -4 tells me too? So it shifted down 4 units. Okay. Notice that I don't use negative when I'm talking about it shifting. I use down. It shifted down 4 units, or it shifts up however many units. We don't use negative or positive when we're talking about how it shifted. We use descriptor words of down or up. So on this next example, we need to ask that same question. Are there any changes being made inside the parentheses?
No.
No, which means I can substitute x directly in for f of x. So I've got g of x equals -x plus 5. So to graph this, where am I going to start? +5. And then what's my slope?
-1.
-1. So down 1 over 1. So here's my new line. What changes happened in my slope? Was it reflected? Okay. It reflected. Did it get any steeper? What number is in front of that x?
Negative.
A -1. The number itself is 1. What's the slope of my original? Positive 1, so 1 as well. So did the steepness change?
Mm-hmm.
No, so same steepness. Did it shift? Did my y-intercept change?
Yeah.
How did it change?
It shifted up. Yeah.
Shifted up 5 units. So same question for this last example, or the last one of this example. Okay. Did I have any changes inside my parentheses?
No.
No. So I can substitute directly in for f of x and make it g of x equals negative 5 halves x. Sorry, off the screen. Okay. So all I did was substitute in my x for my f of x. How am I going to graph this? What's my y-intercept?
0.
0. And then what's my slope?
Negative 5/2.
So down 5/2. And if I need another dot, go back to the origin and go up 5, backwards 2. So what changes were made to the slope? Was it reflected?
No.
Because my slope is now a negative, so there's a negative here, so yep, so it was reflected. Okay. Is 5/2 greater than 1 or less than 1?
Less than? No, greater than.
Greater than, because the bottom number is smaller than the top number. So this means this number is greater than 1. So the steepness is more. So there's more steep. Was there any changes in the y-intercept?
No.
So you can say that it was the same. You can say no changes. You can say none. Any of those words are appropriate. So same, no change, or none. You do not have to write all of those. I mean, you can on your notes just to signify that all of those are talking about the same thing. 2 more examples at the bottom here. Okay. So the slope, or the graph g of x is obtained by transforming the graph f of x equals x. Okay, the same parent function we've been dealing with all week. Okay, the slope of the graph of f of x is changed to negative 1/4, and the y-intercept is changed to 1. So how can I rewrite that equation? Start with g of x equals.
And then they changed
The slope
to negative 1/4.
Okay.
Which would be negative 1/4 x.
So negative 1/4.
Plus 1, which is.
Okay, x plus 1. Now, if we wrote it in function notation, okay, just so that you'll know what it looks like, you would have the f of x there instead of just the plain x. They're the same thing, right? Because we didn't make any changes inside the parentheses, but I want you to be able to notice so that on the STAR test, if you see a f of x inside something, don't panic. Just replace it with whatever your equation is. So in this case, it just happens to be x, so we can just replace it with x like we did there.
Is that a negative X? Or is it just smudge?
It's just my little curly thing there looks like a negative.
I'm so confused.
So yeah, nope, it's just my x. My fancy x that looks kind of funny. Oops, now I erased the whole thing. Okay, there we go. So it says to graph both of them. So you should know by now what the original one looks like, right? Straight through the graph, up 1/1, diagonal. Okay. So that's my original one. And where's my new one going to be?
Up 1.
Up 1.
And then the slope is down 1/4.
Down 1/4. Down 1/4. Up 1, back 4 if you need to go the other direction. So describe the changes that happened. So by changing the slope to a negative 1/4, what changes did that make? What happened to the slope?
Less steep.
Made it less steep and it reflected. So reflected, less steep. And then what did adding 1 on the end do?
Shifted up.
Shifted up 1 unit. So if you've got all that, then see if you can work on that next one. You can at least graph your original, right? The f of x equals x line, you should be able to graph. Okay. And this last example, okay, says that it took the parent function again, okay, and it changed it to the slope to 4/3, and the y-intercept changed to -8. So what's my equation going to look like? G of x
G of x equals 4/3 minus 8.
4/3 f of x minus 8?
Yeah.
Or how else could I write it? With just the x? Oops. So how would I graph that?
You would go down 8.
Down 8. Up 4/3 for my slope. Was this one reflected? So no reflection. Did it get less steep or more steep?
More steep.
More steep, because 4 over 3 is bigger than 1. So more steep.
Shifted down 8.
And shifted down 8. So that's the end of our notes today. Okay, you do have 10 Get More Math problems to do. Tomorrow we will not have a new lesson so that I can help answer Get More Math problem questions, okay, or help with those that have been out this week for different things, okay. So if that you don't get your Get More Math problems done tonight, don't panic. We're not going to have anything new tomorrow, but we will have a quiz on Friday over what we've learned this week.